Friends, this is Piyush Gupta from an Epsilon Institute of Mathematics. Today our topic is on function of bounded variation. So let us start with the definition of total variation on closed interval AB, which is defined as supremum of summation mod of f of xi minus f of xi minus 1, which is denoted by v of fab, right? So here are some properties of variation, that is v of a is equals to 0, v of b is equals to total variation of f over closed interval AB. Now C point is, if x1 is strictly less than x2, which implies that v of x1 is less than v of x2, that is vx is a non-decreasing function. D point is, v of x is continuous if and only if fx is continuous. Now here is an important point, that a function of bounded variation need not be continuous in that interval. Now result of on bounded variation. First of all, if fx is a bounded monotonic function in closed interval AB, then fx is a function of bounded variation. मीन्स अगर fx हमारे पास बाउंडेड मोनोटोनिक फंक्शन है क्लोज इंटरवल ए बी के अंदर, तो fx जो होगा वो बाउंडेड वेरिएशन का होगा, राइट. नाउ if a function is differentiable in closed interval AB and its derivative is bounded in closed interval AB, means function differentiable है और derivative is bounded, derivative bounded है closed interval AB के अंदर, then fx जो होगा वो बाउंडेड वेरिएशन का होगा. एंड ऑल्सो वेरिएशन इज गिवन बाय v ऑफ एफ ए बी लेस देन और इक्वल्स टू m into b minus a, where m is the upper limit of the derivative of function and b and a are endpoints of the interval. Now C point is, function of bounded variation implies that function is bounded. Then if fx is a function of bounded variation in closed interval AB, and if C belongs to open interval AB, be any point, then function fx is a function of bounded variation in AC and CB. मीन्स अगर हमने बीच में कोई भी पॉइंट ले लिया C क्लोज इंटरवल AB के बीच में, तो हमारे पास जो वेरिएशन होगा वो बाउंडेड होगा और उसको हम समेशन की फॉर्म में लिख सकते हैं इस टाइप से, v of f a b is equals to v f a c plus v f of c b, right. उसके बाद if fx is a function of bounded variation on closed interval AB, then it can be expressed as the difference of two monotonic decreasing non-decreasing functions and conversely. मीन्स अगर फंक्शन fx जो है वो बाउंडेड वेरिएशन का है, तो हम उसे एक्सप्रेस कर सकते हैं डिफरेंस ऑफ टू मोनोटोनिक नॉन डिक्रीजिंग फंक्शंस में, और कन्वर्सली भी ट्रू है इसका, राइट. अब फिफ्थ पॉइंट है, इफ f इज अ फंक्शन ऑफ बाउंडेड वेरिएशन देन इट इज रीमान इंटीग्रेबल, बट कन्वर्स इज नॉट ट्रू. देन सिक्स्थ पॉइंट इज, if f and g are function of bounded variation, then mod f and mod g are of bounded variation, f plus minus g are of bounded variation, product is also of bounded variation, but division need not be of bounded variation, right. So seventh point is, if fx is a function of bounded variation in closed interval AB, and if f for each x belongs to AB, mod of fx is greater than और इक्वल्स टू m, मीन्स बाउंडेड नहीं है, तो हमारे पास 1/fx जो होगा वो बाउंडेड वेरिएशन का होगा क्लोज इंटरवल ए बी के अंदर. नाउ डिरिचलेट फंक्शन एंड रीमान फंक्शन आर नॉट ऑफ बाउंडेड वेरिएशन. डिरिचलेट फंक्शन और रीमान फंक्शन जो होते हैं वो बाउंडेड वेरिएशन के नहीं होते. सो नाउ आवर सेकेंड टॉपिक इज इम्प्रॉपर इंटीग्रल. सो हियर इज अ डेफिनेशन ऑफ इम्प्रॉपर इंटीग्रल इज, इफ एफ जो फंक्शन है वो डिफाइंड है हमारे डोमेन में क्लोज इंटरवल ए बी, और मॉड ऑफ एफ एक्स जो है बाउंडेड है, तो अगर हमारे पास जो ए और बी लिमिट पॉइंट है इसके, अगर ये इनफाइनाइट या फिर अनबाउंडेड हो जाते हैं तो वो हमारा होता है इम्प्रॉपर इंटीग्रल. then it is called as improper integral, right? Here there are three types of improper integral. First of all, a definite integral, integration of a to b fx dx is said to be improper integral if either a or b or both are infinite. So that interval is unbounded but the function is bounded. For example, here there are two examples of first kind, that is the integration is 0 to infinity means it is unbounded, and function is bounded means sin x square dx, right? And second example is 0 to infinity e to the power minus x dx. That's it. Our second kind is the definite integral a to b fx dx if a and b are finite but the function has one or more point of infinite discontinuity, that is f is not of bounded on closed interval ab. For example, 0 to 1 1 upon x square dx. Here 0 is the discontinuity point of this function, so it is of the second kind. Now third kind is the definite integral a to b fx dx is said to be the third kind if integrand of f is unbounded, that is a or b or both are infinite, and function is also unbounded, means it is a mixture of first kind and second kind on closed interval ab. For example, 0 to infinity e to the power minus x under root x dx. Here the discontinuity is at 0 and interval is also unbounded. Second example is 1 to infinity and 1 upon x minus 1 whole square dx. So 1 is a discontinuity point and interval is also unbounded. The third example is minus infinity to 0. Here minus 2 is the discontinuity point and interval you can see that it is also unbounded. Our fifth point is a comparison test, that is if the fx dx integration a to b and a to b gx dx be the two improper integral where f and g has only point of discontinuity at x is equals to a. अगर सिर्फ a के ऊपर discontinuity है f और g की, और f and g are two non-negative functions, right? And third supposition is if fx is less than or equals to gx for all x belongs to closed interval ab, then integration of a to b fx dx converges if gx dx is converges, means अगर हमारे पास gx dx कन्वर्ज करेगा तो fx भी कन्वर्ज करेगा, अगर fx डाइवर्ज करेगा तो gx भी डाइवर्ज करेगा. ये हमने लास्ट क्लास में किया था कंपैरिजन टेस्ट, राइट? अगर आप चाहते हो देखना तो लास्ट क्लास में रियल एनालिसिस की क्लास थी, उसके अंदर आप जाके देख सकते हो, राइट? सो दैट्स इट फॉर टुडे. थैंक यू फॉर वॉचिंग द वीडियो. और नेक्स्ट टॉपिक इज अ रीमान इंटीग्रेशन which we done in the next class, right? Thank you for watching the video. Like, share and subscribe. Thank you. Welcome. Bye bye.